Hello children, in today's lecture we are going to discuss about different types of salts. So in our previous discussions already we saw formation of salt in some of the chemical reactions. In this lecture today we are going to discuss more details about salts. Okay, first family of the salts. Here in the activity they asked to write the chemical formulae for the salts given below. So potassium sulfate is K2SO4. K2SO4 is potassium sulfate, and sodium sulfate Na2SO4. Okay, and calcium sulfate CaSO4. Okay, and magnesium sulfate MgSO4. Okay, and copper sulfate CuSO4. Sodium chloride NaCl, and sodium nitrate NaNO3, and sodium carbonate Na2CO3, ammonium chloride NH4Cl. These are the chemical formulae for the different types of salts. So in this activity now they are asking identify the acids and bases from which the above salts may be obtained. So it is easily you can identify. If it is a potassium sulfate, okay, it is derived acid is H2SO4. Okay, and derived base is potassium hydroxide. The acid is H2SO4 and the base derived base is potassium hydroxide. Okay, and the next salt we are taking Na2SO4, sodium sulfate. So for this one derived acid is sulfuric acid H2SO4. Okay, and what is the derived base is NaOH, sodium hydroxide. And coming to sulfuric acid, next calcium sulfate CaSO4. For this one the derived acid is same H2SO4 sulfuric acid, and derived base is calcium hydroxide CaOH taken twice. Coming to magnesium sulfate MgSO4. For this one also acid derived acid is H2SO4, and what is the base? Derived base is MgOH twice, that is nothing but magnesium hydroxide. Coming to copper sulfate CuSO4. For this one the derived acid is again H2SO4 and the base is derived base is copper hydroxide CuOH taken twice. Coming to nitric acid, next one sodium chloride NaCl salt. So for this one what is the derived acid? HCl, hydrochloric acid, and what is the base? NaOH, sodium hydroxide is the base. Next sodium nitrate is the salt NaNO3. For this one what is the derived acid? HNO3, that is nitric acid, and what is the derived base? Sodium hydroxide, again NaOH. Next carbonic, next one sodium carbonate, what that is Na2CO3 salt. For this one what is the acid? Carbonic acid, that is H2CO3, and what is the base? Sodium hydroxide NaOH. And the next one ammonium chloride is the next salt, that is NH4Cl. For this one the derived acid is HCl, right, and what is the base? Ammonium hydroxide NH4OH. This is the derived base for that particular salt. So we can categorize the salts by as a families. Okay, identifying the families of salts. If you do that, So for example, if it is sodium salt, so what are different types of sodium salts? Na2SO4, NaCl, NaNO3 and Na2CO3. These all will come under sodium salts. For example, it is potassium salts, K2SO4, calcium salts, CaSO4, magnesium salts, MgSO4. Okay, and copper salts, CuSO4, chloride salts, NaCl, NH4Cl, sulfate salts. So sulfate salts means K2SO4, Na2, different all sulfates, K2SO4, Na2SO4, CaSO4, MgSO4, CuSO4, they all will come under sulfate salts only. So most of them, all these come under sulfate salts. Okay, what is a salt? So salt is formed when acid reacts with a base, which is a neutralization reaction. Example we can say, for NaOH reacting with HCl gives to NaCl plus H2O. So HO. So here NaOH is the sodium hydroxide and which is a base. HCl is hydrochloric acid, which is acid. They react with each other to form the salt and water. Another observation you can do is positive ion. For example, in the case of NaCl, Na is positive and Cl is negative. So Na is coming from the base and Cl minus is coming from the acid. So what is your conclusion here? The positive ion or cation is coming from the base and the anion or negative ion is coming from the acid. Okay, and categorizing also we can do salts with the same cation come under one family. For example, sodium salts, Na plus, all sodium salts will come under one category, and all the salts with SO4, that is anion, SO4 2 minus, they all belong to sulfate salts. Like that we can categorize. Here one activity is given. So here pH of salts we are trying to observe. Okay, and here what we are doing, understanding the pH of the salts. Acid reacts with the base, it forms salt and water in a neutralization reaction, that you know. Okay, so the pH of a salt solution depends on the nature of the acid and the base that we are using. For example, strong acid reacting with strong base. In that case, neutral salt, that is pH is equal to 7. For example, it is strong acid and weak base. That results, which type can you guess? It becomes acidic salt because we are taking strong acid. If it is a weak acid reacting with strong base, then what you will get? Basic salt. So it becomes a basic salt because basic nature is strong here. So like that you can categorize. So here you know that if it is a neutral salt, pH value will be 7. If it is a acidic salt, pH is less than 7. If it is a basic salt, pH will be greater than 7. So you can observe and you can feel this table. For example, NaCl is one type of salt. So the pH value will be 7. Here hydrochloric acid, HCl is the hydrochloric acid and base use the NaOH. Both are strong. So you are getting a neutral salt here. For next, potassium nitrate, KNO3. So in this case also you will get pH as 7 and the acid used is nitric acid. HNO3 is the acid and what is the base? Potassium hydroxide is the base. So here also you will get neutral type of salt. For example, you take aluminium chloride, AlCl3. Okay, in this case what is you will get less than 7 because here hydrochloric acid we are taking and aluminium hydroxide AlOH thrice. So this is acidic in nature because HCl is a strong acid and aluminium hydroxide is a weak base over there. So similarly you can observe zinc sulfate ZnSO3 SO4 and copper sulfate, right? For these also you will observe it is less than 7 because the acid we are using is H2SO4 in both the cases, and here the bases are ZnOH twice, that is zinc hydroxide, and the second case copper hydroxide CuOH twice. So these are the weak bases compared to sulfuric acid. So both these cases you will get acidic nature of salts. For example, if I am taking sodium acetate, so in this case CH3COONA, that is sodium acetate. Here you observe it is greater than 7 because here the acid we are taking is acetic acid CH3COOH, and what is the base? NaOH is the sodium hydroxide is the base used. Because this is a strong base compared to acid, so you will get basic nature of the salt. Similarly sodium carbonate Na2CO3 is your salt. In this case also you will observe it is greater than 7 because here the acid is carbonic acid. What is carbonic acid? H2CO3. And what is the base? NaOH, sodium hydroxide. Because it is strong compared to the carbonic acid, you will get a basic natured salt. And finally you can observe sodium hydrogen carbonate NaHCO3. So this is the case. In this case also you will observe it is greater than 7, basic in nature. So what is the acid? Carbonic acid, H2CO3 carbonic acid, and sodium hydroxide is the base. So it is slightly basic. So these are the observations that you can do here. So our next topic is chemicals from the common salt. What chemicals that can be prepared using common salt? Here you can see a picture with Mahatma Gandhi ji. So this is related to Dandi March. This is related to Dandi March. You can observe here. So it played a very crucial role in our independence war. Okay, and now we need to identify the importance of NaCl in our daily life. We all know that for cooking purpose daily we are using NaCl. So what are the other chemicals that can be created from the common salt that we are going to discuss now? So here common salt is a raw material for preparation of different chemicals. So here you can observe some of the chemicals that are prepared using the common salt. So what are they? Sodium hydroxide, baking soda, washing soda, bleaching powder, all these substances daily life we are using. So first, how to prepare sodium hydroxide? So when electricity is passed through the aqueous solution of sodium chloride, it decomposes to form the sodium hydroxide. Here clearly it is mentioned. So NaCl, when it is using the electrolysis process, it is getting decomposed to form NaOH, chlorine gas and hydrogen gas. So this process is called chlor-alkali process because of the products formed chlor for chlorine and alkali from sodium hydroxide. So chlorine gas is given off at the anode and hydrogen gas at the cathode. Sodium hydroxide solution is formed near the cathode. The three products produced in this process are all useful. So that is explained here. So first we observed that we can prepare sodium hydroxide using common salt, right? So using the electrolysis process. So in this picture you can observe. So in the reaction we are using brine, that is salt water, which is electrolyzed using these two. Anode and cathode are kept inside this brine. Okay, and after the reaction you can see the formation of NaOH, right, and chlorine gas is getting released and hydrogen gas is also getting released. So these chemicals are further used to produce bleaching powder, PVC, disinfectants and many more. Okay, importance of a common salt in the industry, food industry, used for preservation and seasoning, right? Chemical industry, raw material for many compounds. Water purification, chlorine derived from the salt, right? This disinfects drinking water. And in the textile and paper industry, used in bleaching and dyeing. So like this, multiple uses are there using this char alkali process. Okay. So here bleaching, how to prepare bleaching powder, that is shown here. So once we got chlorine from the above reaction, chlor-alkali process. So using that chlorine, when this chlorine reacts with the CaOH, right, then it produces CaOCl2, which is nothing but bleaching powder, and water is getting released here. Okay, and this bleaching powder is produced by the action of chlorine on dry slaked lime. So this is known as the dry slaked lime. So it is in bleaching powder that is represented as CaOCl2. Okay, you know how it is useful. Bleaching powder we can use for multiple purposes. Cotton and linen in the textile industry, for bleaching wood pulp in paper factories, and for bleaching washed clothes in laundry, as an oxidizing agent in many chemical industries, and to make drinking water free from the germs. So very important product, bleaching powder. Coming next one is baking soda. So it is commonly used in the kitchen for making tasty crispy pakoras. Sometimes it is added for fast cooking also. So how it is prepared, what is the composition? It is baking soda means sodium hydrogen carbonate, NaHCO3. It is also produced using sodium chloride as one of the raw material. So you can see the chemical equation here. NaCl is the raw material here, water, carbon dioxide and ammonia, NH3. So here the products are ammonium chloride and sodium hydrogen carbonate, which is nothing but our baking soda. Baking soda mainly it is used in the cooking purpose. So did you check the pH of the sodium hydrogen carbonate in the activity? So here we can find out it is a mild non-corrosive basic salt. So if you test it, it is a non-corrosive basic salt. Okay. When it is heated during the cooking, what happens? Baking soda, if it is heated, again it will form sodium carbonate, water and carbon dioxide. So sodium hydrogen carbonate has got various uses in the household. Another one, baking powder is, you may be knowing about this one also. Baking soda and baking powder, they are different substances. So how baking powder is prepared is, it is a mixture of baking soda and a mild edible acid such as tartaric acid. When baking powder is heated or mixed in water, the following reaction takes place. So baking powder is mixed with water. What happens? It releases carbon dioxide, water and sodium salt of acid. So here this carbon dioxide produced during the reaction can cause bread or cake to rise, making them soft and spongy. Whenever you prepare cake, definitely we add baking powder to the maida. So if you don't add that baking powder, that fluffiness to the cake you cannot observe. So that is the use of this baking powder. And sodium hydrogen carbonate is also an ingredient in antacids. Okay, and because it is alkaline in nature, it neutralizes the acidity. Much extra acid present in your stomach. So even you can use for the soda, right, as a gas in the soda, and you can use in the acid fire extinguishers also. The next one, washing soda. How to prepare washing soda? So this can be obtained from sodium chloride, and the combination is Na2CO3 10H2O is the formula for the washing soda. So sodium carbonate can be obtained by heating baking soda. So recrystallization of the sodium carbonate gives washing soda. So how it is coming, you can observe here. So sodium carbonate 10H2O, it is getting Na2CO3 10H2O. So what does this 10H2O signifies to? So Na2CO3 wet. Okay, that we will see. So here sodium carbonate, which is washing soda, used for in the glass, soap and paper industries. Okay, washing soda is a important ingredient in preparation of the detergent, soaps, liquid detergents, everything. So sodium components such as borax, sodium carbonate can be used as a cleaning agent for the domestic purposes, right? It is used for removing permanent hardness of the water. So that they are the uses of the washing soda. So here in this are the crystals of salts really dry? That we are going to test in this activity. So here basically salt crystals may appear dry, but they often contain water molecules within their structure. So these are called water of crystallization or hydrated salts. So the types of salt crystals: hydrated salts contain water molecules. Some salts trap water molecules inside their crystalline lattice. These are called hydrated salts and have specific number of water molecules per formula unit. So for example, copper sulfate pentahydrate, if it is, so you will write it as CuSO4 5H2O. So the meaning is blue crystals contain 5 water molecules. For example, washing soda, just now we observed that Na2CO3 10H2O. The meaning is it contains 10 water molecules. Gypsum CaSO4 2H2O. So it contains 2 water molecules, right? So next, anhydrous salts. So here when hydrated salts are heated, they lose water and become anhydrous, dry. So anhydrous copper sulfate means simply CuSO4. So there is no water content in this one. White powder obtained by heating blue hydrated copper sulfate 5H2O. So similarly, anhydrous calcium chloride means simply it is CaCl2. Okay, used as a drying agent. Okay, desiccant. So how to check if a salt is dry? How the checking process is, you can heat the salt. If water evaporates and the color changes, for example CuSO4 turning from blue to white, it was hydrated. Touch the salt. Some hydrated salts feel slightly damp. Exposure to air. Some anhydrous salts absorb water from air and become hydrated. Example CaCl2 and NaCO3. Like this you can check the dryness of the salts. So you all know about this plaster of Paris, right? We use this for making this dolls kind of thing. So what happens? Heating gypsum at 373 Kelvin, it loses water molecules and become calcium sulfate hemihydrate. Okay, this is called the plaster of Paris. So main use of plaster of Paris is for the when you get a fracture. So for this supporting our bones, fractured bones, we use plaster of Paris, right? So it is a white powder, and on mixing with water it changes to gypsum, once again giving a hard solid mass. Okay, so here the formula is given: CaSO4 half H2O reacting with 1.5 H2O. Again it is giving CaSO4 2H2O, which is known as gypsum. So plaster of Paris reacting with water. So half water molecule is shown to be attached as water of crystallization. So how to get this half molecule? So this we need to observe. Okay, and even you use plaster of Paris for making toys, materials for decoration and for making surfaces smooth. So these all you will find in the daily uses. Okay, in our next lecture we discuss about the questionnaire and the concluding part of this lecture. Thank you.